Okay, let's talk about the solutions to episode 3, which was about names, values, and types. If you haven't already taken a crack at them yourselves, please go to this video and give it a try, or go to my GitHub page. Link is in the description, and pull out the Jupyter notebook from that. There are 3 tiers of difficulty. There's warm up, intermediate, and advanced. So jump into the problems that interest you, that are at your level. So tier 1 is the warm ups. So assign your name to a variable called name and your age to a variable called age. Print a sentence that uses both. So the question here is, do you understand variable assignment? So the equals means assignment in Python. In R, it goes so far as to use an arrow instead of an equals, which means that you take this value and then you assign it to this variable. So it's not an equals in a mathematical sense. Python, you just use equals. So I make a variable called name. It contains the value mark. Make a variable called age. It contains the variable 20. It contains the value 29. And then I print my name is, and then the value of the variable name. So with an F string, you put curly brackets around the variable. And instead of printing name literally as a string, it will take the variable name. So my name is, it'll say Mark, and I am, whatever age is, 29 years old. And it did. Problem 2 is about types. So as a Python will infer the type of a number or an expression or a variable from the context. In some languages, you have to specifically say, I have this variable, I have this type. In Python, it figures that out for you. So it's called dynamic typing. So print type of 3.0, that should be a float, which is computerese for a decimal, a number with a decimal in it. Type 3 is just an integer. There's no decimal. Let's see if that's correct. Yeah. So the type of 3.0 was float. Class of 3 was an integer. Problem 3, predict what this prints, then run it in check. So X is 10, Y is 3. Do assignments from right to left. So X plus 3, 10 plus 3 is 13. Then it's going to assign it to the variable X. So X is 13. And line, line 3 here, this will overwrite line 1. So once you do this, your initial value of X is gone forever. It's been overwritten. And it does, in fact, print 13. Problem 4 is variable names. You cannot start a variable with a number. Python will try to interpret that as a number and then get confused. Yeah, so it's invalid decimal literal. It's trying to read too fast as some sort of float or something, and it gets confused. So the fix is don't do that. Just start it with a letter. So too fast as TOO, the word. Okay, that works. And then let's print it out just to convince ourselves. Yep. Problem 5, convert the string 1984 to an integer and multiply by 2. What do you get? Integer 1984, put that in a string. Then I have the string, which is text, but it contains a number. So it's the same as a word or something. It's just a string of characters not being interpreted as a number. And then I say, well, cast that to an integer. So it casts the string to an integer. At that point, it will be the number 1984, and then you can multiply it. Tier 2 is intermediate. So problem 6, Python lets you do multiple assignments on one line, predict what this prints, then run it in check. So ABC equals 1, 2, 3. A will be 1, B will be 2, C will be 3. So this should print out 1, 2, 3. AB equals BA. Again, look at this from the right-hand side first, and then see what those values are and assign it to the variables on the left. So B is 2, A is 1, AB equals 2, 1, A equals 2, B equals 1. So we'll print 2, 1. So essentially it's swapped A and B. A is the previous value B, B is the previous value of A. Let's see if it actually does that. And it does. Print ABC is 1, 2, 3. After swapping them, print AB is 2, 1. Problem 7, Python lets you swap two variables in one line without using a temporary value, swap X and Y. So, yeah, so X is initially hello, Y is initially world. Put some code here, and then when you print them out, they've been swapped. So to do that, we just saw this in the last problem. You just say XY equals YX, and then it'll swap them again because it does the right-hand side first. So Y is world, X is hello. Now XY will be world, comma, hello. So X is world, Y is hello. And that worked. You might wonder, what are they talking about, this temporary variable business? So you might be tempted to put that in 2 lines. It won't work. So X is hello, Y is world, X is Y, Y is X, and then print them out. The problem with this is that line 4 overwrites line 2. So when X is equal to Y, at this point Y is world, X equals world, then Y equals whatever X is. X was just set to be world. So now Y is also going to be world. So this is going to print out world, world. Okay. So the way around that, if you didn't have this one line multiple variable assignment, the way around that would be to create a temporary variable. So X is hello, Y is world, T is hello, X equals Y, which is world. Y, I can't set it equal to X because that's been overwritten, but I did save it into T. So I can say Y equals T, and then Y will be hello. So that works, but I think you'll agree it's much easier just to say XY equals YX. So Python. Problem 8, what is this print and why? So print 0.1 plus 0.2. Is it equal to 0.3? Well, mathematically, yes, but does Python know that? So we saw, if you watched the lecture, you saw that there'll be a little bit of garbage on the end of 0.1 plus 0.2. Type that in wrong. And if I do the calculation, yes, indeed, there's a little bit of garbage. This is an artifact. It's not a Python thing. It's a computer thing. So computers, well, not quantum computers, but that's a different thing. Computers store values in binary, and sometimes a decimal will not fit nicely into the binary scheme. And so as an artifact of that, it may add a little bit of junk on the end. So if I ask it, is 0.1 plus 0.2 equal to 0.3? No, it's not. because 0.3 full stop is not equal to 0.3 blah, blah, blah with the 4. The way to fix this, just round it. So 0.1 plus 0.2 is 0.3 rounded to 1 decimal place. That'll chop all this off. And then it is, in fact, equal to what we want it to be. Problem 9, the user types their birth year into a Python program using input. Write code that computes and prints their approximate age in minutes. Remember, input always returns a string. So the age in years, I do the input, I'll get the age, that's a string. As we saw a little earlier, we can convert that, assuming it's something that can be reasonably converted into an integer. We just cast it. Then the age in minutes, there's 365 days in a year, 24 hours in a day, and then 60 minutes per hour. So if I multiply that out, that'll tell me how many minutes. So I have lived for 134 years, and that's this number of minutes. Yeah, let's look at the F string. You have lived for approximately, since it's an F string, a formatted string with that F before the quotations. Anything in curly brackets will be the variable, the content, the value of that variable. So it'll give me the age in minutes. This odd looking colon, comma. The colon in this context says I want to format the string in some way. And for this format, I want it to have a comma. So that's why it says 70, what is that? 70 million, comma, 430,400. Problem 10, you have a temperature in Celsius, converted to Fahrenheit, and print the result rounded to 1 decimal place. I'll give you the formula. Try it with different values. Why is the last one interesting? So I get the input from the user, cast it to an integer, use the formula, print it out. Temperature in Celsius, let's try 100 first, which is boiling point of water in Celsius, should be 212 Fahrenheit. Enter, not control, enter. There we go. Let's try it again. This time is 0. That's freezing. Should be 32. It is. What is negative 40? That's negative 40 degrees in Fahrenheit. So it's the same in both scales. Tier 3, challenge problems. So these are more puzzles. So in numbers, digits. Given any 2-digit number, say 47, use the integer division modulo to extract the 10 digits and the units digits separately, then print their sum. And can you generalize this to a 3-digit? So let's try it with 47. To get the tens place, I can integer divide by 10. So 10 into 47 is 4, remainder 7. Integer divide just grabs the 4. Then the units will be the remainder. It was 47 divided by 10 is 4, remainder 7. 7 is the units. Okay. So that gives me tens, it gives me units. Then the total of the digits is tens plus units, and then I print that out. To generalize it to 3 digits, let's say we have 987. Hundreds is the integer division. 987 divided by 100 is 9, remainder 87. So the remainder will be 87. We can then use that remainder to pull off the tens and the units. So tens is 87 divided by 10, 8. Remainder 7, so that gives us 8 and 7 for tens and units respectively. Add that up. 9 plus 8 plus 7 is 24. Problem 12, make some change given an amount given in cents. It's a very similar process here. So we're given some payment value, some purchase. The change is the payment minus the purchase. I'll print that out. The dollars is the change divided by 100. And then the change is that remainder. And then from that remainder, we divide integer divide by 25. That'll give you number of quarters. Then you have some change from that. Then dimes is that change divided by 10, integer divided, and then the remaining change is that remainder. The nickels you integer divide by 5, and then whatever's left over will be the pennies. So here our change is 367 cents, $3. Okay. Does the rest of this add up to 67? 2 quarters is 50, plus 10 is 60, plus 5 is 65, plus 2 is 67. That worked. Problem 13 is asking about leap years. It's really asking about modulo and using modulo inside of logical expressions. So the heart of the problem is, can you convert this to a logical expression? So we have these conditions. Year is a leap year if it's divisible by 4, except century years, unless they are also divided by 400. So 1900 is not a leap year, but 2000 is. So year with 1900 is leap. Is it divisible by 4? If the remainder divided by 4 is 0, that means it's divisible by 4. Is it also not divisible by 100? Or is it divisible by 400? So 1900 is not a leap year. 1904 is, 2000 is, 2020. Okay, seconds time, give a number of seconds, compute and print how many hours, minutes, remaining seconds that represents. This is similar to the change problem. We have seconds. Number of seconds in an hour is 3,600. So to get the number of hours, I divide it by 3,600. Then that gives you a remainder in seconds. And then I can use that remainder to calculate the number of minutes, just divided by 60, and then the remainder is the remaining seconds. Print it out. Compound interest surprise. You deposit $1,000 at 5% annual interest using only variables and arithmetic operators, no loops, no functions. Compute the balance after 1 year, 5 year, 10 years, and there's a formula. How many years does it take to double? So try to get to 1 year just using an exponentiation. You could run this through a loop and pull out the right answer, but let's see if we can just do it on the fly. So we have a principal, we have a rate, the balance after 1 year. It's the formula with years of 1. After 5 years, years is 5. After 10, it's 10. Print that out. Okay. Balance after 1 year, 2 years, 10 years. 10 years has not doubled yet. So let's try 20 years. Okay, so it's certainly doubled by 20 years. It's more like 2.5 times. So that's probably not the year that it doubled. Probably after that. So let's try 15. Okay, here the balance after 15 years is 2,000 and some change. I'm going to guess that 14 has not doubled yet. Let's double check that. And it has not. It's a little under. So I'll say the balance doubled after 15 years. And that's our answer. Okay, so those were the problems. I hope this helped and was interesting to you. Yeah, so I'll see you in the next one. Happy programming.